In this lab, we will be determining the R value in the ideal gas equation. Here's some of the equipment that will be used in this experiment. The eudiometer is a device that allows us to collect gas and measure its volume. This tall form beaker will be necessary in order to have water levels that are high enough to reach the values on the eudiometer, and the analytic balance is used to determine high precision values for the mass of the magnesium. Next, we're going to need a piece of magnesium. The magnesium needs to be between 0.045 grams and 0.05 grams. If we go over the 0.05 grams, we may produce too much hydrogen gas for the experiment to give us valid readings. We'll need to cut a piece of string in order to tie the magnesium down. This will prevent the magnesium from floating away later on in the experiment. Next, we'll take the eudiometer and tilt it at a 45-degree angle and measure out 10 milliliters of 6 molar hydrochloric acid. The hydrochloric acid is poured down the eudiometer so that it sits in the bottom of it. After all the acid is added, we'll take distilled water and gently pour it down so that the distilled water forms a layer on top of the hydrochloric acid, which remains sitting at the bottom. We don't want too much mixing to occur during this process. The eudiometer should be filled all the way to the top. The magnesium is then inserted down into the eudiometer below the water level. You'll usually want it to go a couple centimeters down below, just to make sure the magnesium stays in the tube and doesn't fall out during the next process. Placing a finger over the open end of the eudiometer is turned upside down and inserted into the tall form beaker filled with water. The eudiometer is pressed all the way down to the bottom so as to make sure that the string is caught underneath it, preventing the magnesium from floating away during the experiment. A shimmering effect may be noticed due to the diffraction of light as the hydrochloric acid and water mix. Once the acid reaches the magnesium at the bottom, you'll notice that bubbles start to form. As the reaction continues, the bubbles will go to the top of the eudiometer. Trapped, they will force the water level further and further down. As the reaction progresses, it tends to move faster and faster, until eventually all of one of the reactants is completely consumed. At this point, the water level inside the eudiometer and the water level in the beaker will need to be adjusted in order to make sure that they are the same, both inside and out. This may involve raising the UDiometer up, or it may involve adding more water to the beaker. At this point, the final volume in the UDiometer is measured. Be careful that this is reading down instead of up like most graduated devices typically read. At this point, we've only collected the volume. We'll also need to know the temperature of the gas, which we can assume should be roughly the same as the temperature of the water. We'll also need to know the pressure of the gas inside the tube. We can use the room pressure in order to figure that out.